In this video, we're going to go over how to use constraint layout using Jetpack Compose. And if you've been around Android development for any amount of time, I'm sure you've used constraint layouts when you are building your layouts. This was the recommended way by the Android team to build especially complex layouts on Android. They recommended don't nest relative layouts, don't nest linear layouts. You should be using constraint layout because it is more performant. Well, this is not the case with Jetpack Compose. You actually do not need to use constraint layout if you have complex layouts, rows, columns, boxes, surfaces. All these things are perfectly fine. It does not seem to affect performance in the same way that nesting relative layouts, nesting linear layouts did when using XML. So just kind of, if you want to know how to use constraint layout, continue watching this video, but know that it is not necessary to use constraint layout. And it's actually kind of complicated. I would say, generally speaking, rows and columns are far easier to use. But if you want to build something complex where you have things arranged relative to one another, then keep watching this video. This is the one for you. So specifically speaking, what we're going to do is we're going to build a couple layouts. They're going to be very simple layouts. I'm going to show you probably 4 different examples. So if this is our app here, we have our kind of, our search bar up here. Whoops, that's not how you spell search. We have our search bar up here. What I'm going to do is I'm going to show you 4 different ways to build this layout. There's going to be a loading progress bar that sits kind of in different orientations, and then it's going to have some text that's aligned down below it that's going to say loading. So I'm going to show you how to, align it from the top, different amounts, make sure to align it to the edges, align it to the bottom, basically all the standard constraint layout stuff that you would need to do with XML. Also, obviously, how to align these two relative to one another. Let's start by taking a look at the constraint layout section for the Jetpack Compose documentation. So developer.android.com, Jetpack, Compose, layout, and then scrolling down to the constraint layout section. So if I read this, it says constraint layout can help place composables relative to others on the screen, and it is an alternative to using multiple rows, columns, and stack elements. Stack is actually deprecated. Box is the replacement, I believe, or I'm not sure if it's the replacement, but that's what I use if I want to overlay composables on top of one another. You saw that in the previous video. Constraint layout is useful when implementing larger layouts with more complicated alignment requirements. So generally speaking, you can probably accomplish whatever you need to accomplish with rows and columns and box, but if it's something super complex, then constraint layout might be what you're after. Notice this note here. This is very important. So note in the view system, constraint layout was the recommended way to create large and complex layouts, as a flat view hierarchy was better for performance than nesting views are. So basically what that says is before we recommended using constraint layout instead of nesting relative layouts, linear layouts, that kind of stuff. But it says, however, this is not a concern in Compose, which is able to efficiently handle deep layout hierarchies. So I mentioned this at the beginning of the video. I said that it's not necessary to use constraint layout. Rows, columns, boxes, all these things are perfectly fine. It's not going to affect performance like it would with XML, but I'm going to go through some examples anyway because you might have some complex layouts and you don't know how to build them. So I'll show you how to use constraint layout with Compose. So let's go into our circular indeterminate progress bar because this is where we're going to be doing all of the work basically in this video. So I'm going to show you 4 examples, like I said. Now I want to get rid of this row scenario that I have here. So I'm cutting the circular progress bar and I'm going to paste it over the row because we're not going to use that row anymore. We're going to use a constraint layout. So we can create a constraint layout with Jetpack Compose like this. And I'm going to add a simple modifier to this that just says fill maximum size. So I'm adding a constraint layout and it's going to occupy the entire, possible height and the entire possible width. This is important if you want to center things, obviously, because if you center something and it's not occupying the entire width, then it's not going to get centered. So occupying the entire width is important. Now, this is where it gets a little weird. And I think constraint layout has a weird feel with Jetpack Compose, but it will make sense by the end. So the way that you do this is you declare variables and you kind of tie them to IDs, I guess you would say. Like previously in a relative layout or a linear layout or a constraint layout in an XML, you'd give it an ID and then that's how you align it to something else. So this is how you give something an ID, I guess, essentially with Compose. So I would say like value, I could say value progress or progress bar even, progress bar equals create ref. So what that does is it creates an ID essentially, and you can create multiple IDs with a different way to kind of initialize this. So instead I'm going to use a bracket and do progress bar comma text, and then say create refs. So what that'll do is the same thing as create ref, but it's going to create two IDs, progress bar and text are those two IDs. Now I want to tie those IDs to particular composables. So for us, one of those composables is the circular progress indicator. So I'll come up here and I'll paste that in. Now I can kind of set an ID by setting a modifier parameter. So I'll say modifier.constrain as, and then I'm going to pass that progress bar. I need a comma here because I added that other attribute. So constrain as, and then I want to open this up and I get access to a lambda into this kind of constrained scope. Now this constrained scope gives us access to a bunch of other stuff. So I can do like top. Ooh, this is kind of giving me some weird alignment issues here. Let's bring this over here. Okay, there, I got it. I just played around with it. Looks like that. That's probably the best view I can offer you guys. Okay, so modifier.constrain as, then you pass the progress bar or whatever ID as an argument. And now I can kind of add the constraints to this thing. So if we look at the constrained scope, so let's actually, I'm going to hold down control and click on this. And this will take me into constrain as. Now I want to look at this constrained scope. So control and click on this. There's a bunch of things that are available to me. I have parent, which would be the parent. I can align it to the start, the top, the end, absolute right. Basically what you can see here is all of the stuff that would be typically associated with a constraint layout. So if I go back, the way I can constrain this then is, say, if I want to constrain the top of this, I would say top.link to, and then I can link to something else. In our case, I want to link it to the parent. So I would do parent.top. If I want to then link it or constrain the bottom, I would do bottom link to parent.bottom. See, now it's doing another weird alignment thing. There, I don't understand what's happening, but there we go. That looks better. Now start.link to and do parent.start, and you can do end.link to and then parent.end. So essentially what that just did is that's basically just adding a constraint to the top, to the bottom, to the start, and to the end. So that would align it directly in the center. So now what about the text? That text that I was talking about that's going to sit down below the progress bar. How do we then align this below the progress bar? So first we need a widget, obviously, just like with our circular progress indicator, that was a widget. So let's add one down below it. So I'll create a text widget. The text here will just say, loading ... or whatever you want it to say. I'll go to the next line. And then the next attribute here will be the style. I'm just going to add some basic text styling to this. So text style, we'll do, color equals color.black. We'll do font size equals text unit. So text unit dot companion dot sp, and we'll just do, 15 sp or something like that. Now I want to do the same thing I did up here with the progress indicator. I want to do modifier constrain as, and then pass the ID. In this case, it will be text. So coming up here, let's do coming down here, let's do modifier.constrain as text, because that's that ID. Now open this up and I have access to that constraint scope now. So instead of aligning it to the parent or aligning the top to the parent, I'm going to do top.link to and then reference that other ID. So I would do progress bar.bottom. Then I'm going to do start.link to the parent.start. That'll center it, or I'm going to work on centering it. So end.link to parent.end. So it's going to be centered horizontally because I'm aligning it to the start and aligning it to the end. And then the top is going to be aligned to the bottom of that progress bar. So this will work. This will give us our desired outcome. So let's run this and take a look. So there's the app running, and you can see that loading animation in the middle, or that loading progress bar. That didn't really show for that long. So let's actually go into the view model. And I'm going to change this delay to like 10,000 milliseconds, just so we have like a longer amount of time that we can take a look at it before it fades away. So let's run that again, and again, take a look at our progress bar. So there's the app launching, and we should see our progress bar in the middle. There it is, progress bar, and then loading. Notice it's centered starting from here, and the bottom is here. So that's the center position. It's not centered from the top here because the parent starts here and it ends here. So it gets centered between the top being here and the bottom being here. So that's how you align things relative to one another using Constraint Layout and Jetpack Compose. You just create references, then you use the modifier constraint as, constrain whatever ID that is, and then align it to either the parent or another one of the IDs like we did with the progress bar and the text down here. So that's fine, but what if we wanted to align it kind of in a special position? Like say we wanted to draw an imaginary line right here, and I wanted to align the progress bar to that imaginary line. So this is actually really easy with Jetpack Compose and Constraint Layout. You can create these imaginary guidelines, and they can act as reference points that you can align to, just like the parent. Like the parent has a top, bottom, start, end. You can create a guideline for top, bottom, start, or end and put it pretty much anywhere. So I'll create a new variable up here called a top guideline and set that equal to create guideline from top. And notice all of the constructors here. We have guideline from top, guideline from bottom, absolute left, absolute right, and so on and so on. There's a bunch of guidelines. So the one I want is guideline from top, and it takes an argument that is the offset and the fraction. There's actually a couple different constructors. See, it says multiple implementations. I'm going to use the one that takes a fraction as input. So what this means is I passed 0.3 as a float. So I'm going to create a guideline that is 30% from the top of the screen. So that's what we want, right? Like I said, we want a guideline that's about, I don't know, right around here. So it would be, that's about 30% from the top of this. This would be like 0, and then this would be 100%. So 0.3 or 30% would be somewhere around here. So now instead of aligning the top of the circular progress indicator to the parent top, I'm going to align it to our top guideline. So we've drawn this imaginary guideline, and now I'm going to align it. So because I have this guideline and I want it to be kind of aligned right up top to it, I'm going to get rid of the bottom constraint. That way the progress bar isn't going to get pulled downwards. So let's run this and take a look. So there's the app launching. We expect to see our progress bar about, oh, it's actually quite a bit farther. So it's 30% from here to here. That's what that means, where this would be 0 and then down here would be 100. So that's 30% downwards. That's our guideline. Now, just as another example, say I wanted to, align it to the bottom for some reason. I can say align guideline from bottom. I could say, I don't know, I want to be like 0.3 from the bottom. Sure, let's do that. And we'll change this to bottom guideline. So bottom guideline, and then I'll do bottom.link to that bottom guideline. So now what it's going to do here, I'll run this, and what it's going to do is it's going to have that progress indicator 30% starting from the bottom. So it's going to go up about 30%. So there's the app launching, and then there's that loading progress indicator. Now we're going to talk about something known as decoupling the constraints. So this kind of pattern or technique that I'm going to show you that's available with Constraint Layout is going to be good for if you have, you want to show something different for portrait and then something different for landscape mode. We can actually write some logic, and we can check if the height is like less than, or the width is less than 600 dp, then we know that it's portrait. If the width is greater than 600 dp, then we know it's landscape, and we can create different constraints for Constraint Layout given those different scenarios. So what I want to do here is I want to be able to check the screen size and then, change the parameters depending on the screen size. Just for the sake of an example, say we wanted to use a different fraction depending on if they were in landscape or they were in portrait. That's a simple example, not really realistic probably, but I think you'll get the idea. So the first step here is we want to kind of, abstract out the constraints. So currently we're using constraint as and then defining the constraints in here, constraint as and then defining the constraints. We want to abstract those out so that depending on the screen size, there would be different constraints. So I'm going to create a function down at the bottom here. And this isn't going to be a composable function. It's just going to be a private function. Private function, we'll call it my decoupled constraints, and it will take one variable as input. This will be the vertical bias. Like I said, we're going to assume that for a portrait, we want something other than what we want for landscape. It's kind of a silly example, but I think you'll get the idea. Now I want to return a constraint set, and don't worry about what that is right now. Let's just write this out, and I'm going to go over this when we finish it up. So I want to return a constraint set object, and inside of this constraint set scope, I can define the constraints. So essentially this kind of creates the same thing we have here. So here we have the constraint scope, and I have access to all of these constraint variables. So that's what I've done here. I've created this constraint set object, and now I have access to the scope again. So I can do value guideline and set that equal to create guideline from top, and I'll do that vertical bias as the variable because that's the thing that's going to be different depending on portrait or landscape. Now I want to do my progress bar variable. So progress bar equals create reference for, and then give this an ID of progress bar. So this is like in XML when you had find view by ID or give an ID to something in XML. That's pretty much what this is. I'm saying create a reference for something and give it an ID of progress bar. So I want to do the same thing with the text. So I can say text equals create reference for text. So now I have two IDs that are defined and I want to tie those to a different sets of constraints. So I can say constrain, and I want to pass the reference. So I'm talking about the progress bar ID. Open this up and then define its constraints. So I can just copy these from what we have up here. Well, that's actually bottom, but whatever, we'll copy that and I'll change it. So this should be top and then align it to the top. And then second, we'll do constrain again, reference that text, open this up. And this one I can copy. It's going to be exactly the same. So top, start, and end. So now I've defined some constraints and tied them to particular IDs. So I'm sure you can probably infer what we're going to be doing. We're going to be, returning this constraint set and then accessing them based on their IDs for the particular composables. So there's our, set of constraints. Now let's scroll up and continue on up here. So now the question becomes, how do we know if it's portrait or it's landscape? Well, we can use this with constraints composable. This with constraints composable gives us access to things like the minimum height, the minimum width, basically just things that are present on the screen, like screen properties, I guess you could say. So first of all, I want to say modifier equals modifier.fill maximum size. We always want to fill the maximum size, like I said, because otherwise centering things is going to look really dumb in a constraint layout. It's basically not going to work. Now inside of this with constraints composable, I have something called a with constraint scope. And if I click on this, so control click on this and go into this with constraint scope, it gives me access to minimum width, minimum height, maximum height. So these are all calculated based on the screen size. So now I can write logic based on those things. So, I'll actually do, I'll do value equals constraints and set that equal to this if statement. And inside this if statement, I'll say minimum height, which is accessible now inside of this with constraints scope that we have. If this is less than 600 dp, that means we're in portrait mode. So I'll write a little comment here that just says we are in portrait mode. So in that case, I want to call my decoupled constraints and I can pass a vertical bias of 0.3. So that's like what we had before. If you come down here, that's what we have, right? We have our 0.3 vertical bias, although this is a guideline from the bottom. Now it's going to be from the top. So when we get that, then we can do an else case and do my decoupled constraints. And, just for the sake of doing something different, we can say if it's landscape mode, then we want to do a vertical bias of 0.7. Whoops, I have an extra equal sign up here. So those will define our constraints. So pretty handy stuff. So now I have this constraints variable and I can use it for my different composables. So let's go into our constraint layout now. I'm going to cut this. So cut this entire constraint layout and get rid of this white space. And I'm going to put it inside of this with constraints composable. So I pasted that inside of the with constraints composable because now I can use these constraints. So now this becomes very simple. We don't need any of this stuff. We don't need the constraint as modifier. So I can get rid of that. We do still need a modifier. So modifier equals modifier dot layout ID, layout ID, and then I can reference the string that defines that layout ID. And for the progress bar, that means progress bar. So if you recall down below in our my decoupled constraints function, I created a reference or I created constraints for the ID of progress bar. So that's what I'm accessing right here. I'm saying modifier layout ID and I'm referencing that progress bar. So then it will find the constraints. So I can do the same thing with the text. So I'm going to copy this modifier, come into here and just paste over the current modifier. And then of course change this to text because that was the ID that was used down here. So it's pretty cool. Obviously it definitely cleans up what we were doing in here. I mean, I don't know. Arguably not also because you have this extra stuff you have to use with constraints. But if you have something or different layouts that you want to use for different screen sizes, then I guess this makes sense. I just realized also I forgot something. We have to pass this constraints variable to the constraint layout. So constraint layout and do constraint set equals constraints. That will make the the progress bar and the text layout ID accessible. So yeah, like I said, it definitely doesn't really save on overhead, I wouldn't say, but if you have a complex layout and you want to adjust things for portrait or landscape or do some other, complicated thing, then this might be the best way to do it for you. And you can decouple the constraints from in the composable by building a function like this, where you build an ID, define some constraints for that ID, and then you can just reference that ID inside of the constraint layout that you use. Whoops, one last thing before we run it. I made another mistake. This should be minimum width. So min width, not min height. If the minimum width is less than 600 dp, that means we're portrait. Minimum height, that does not make sense. So let's now run this and take a look and see if we are getting the expected behavior. We should see a different vertical bias for portrait mode as opposed to landscape mode. So there is our portrait mode. So that should be 30% from the top. Yes, that looks about 30% from the top based on the top of this progress bar. Now let's rotate this and we'll do another search. So if I click on soup, there we go. You can see the vertical bias is clearly much larger. This is about a 0.7 vertical bias. So we see that our constraint layout is working correctly. Now we're going to go back to a very, very simple implementation. So I'm going to delete the my decoupled constraints. I'm going to, oh, by the way, I'll put a gist down below that contains all these examples if you want to just, take a look at them later, because this is not going to be in the source code. So I just, I'm going to cut out the constraint layout there and just paste it up here, get rid of the constraint set, and I'm just going to go back to how we were doing this before. So I'll say, value progress bar equals create reference. We just need one. I'm going to delete this text. We're not going to be using that. And I can delete this this layout modifier. Let me actually cut this, and I'm going to put it down below the color, and I'm going to write constraint as, and do progress bar. Open this up, and then just apply some basic constraints. So top link to parent.top, and then let's do start link to parent.start, and then end link to parent.end. Just a simple example now. I'm going to leave this in the source code, even though it doesn't matter. We could have used that row thing that we were doing originally. I just want to leave some kind of a constraint layout example in the source code. So we're going to use this kind of simple one. And of course, don't forget the guideline for the top. So value top guideline equals create guideline from top, and we'll do a bias of 30%. And then we will align that to the top guideline. So just do top link to that top guideline. So running that, let's take a look at the app. Here it is running, and there's our progress bar kind of floating about 30% down. So that's doing exactly what we want at this point. And of course, don't forget to go into your view model and change this back to like 1000 milliseconds, because otherwise you're going to be sitting there and waiting forever to get data from the API. So that's it. Hopefully that was helpful. That showed you kind of everything you need to know about Jetpack Compose and Constraint Layout. Basically, the punchline, in my opinion, is you don't really need to use it, and you should only use it very, very sparingly if you have complex layouts that are crazy. It just overcomplicates things, in my opinion, because it's not going to improve performance. So why overcomplicate things? Rows, columns, boxes, those are the things that you want to use. Before you go, leave some New Year's engagement. Today, if I planned everything correctly, today should be December 31st. So this is New Year's Eve, I guess. And since it's COVID, this is the COVID special. I know probably most people aren't going out because you're not allowed to go out, or you probably shouldn't be going out because you spread that disease. So sit at home, relax, go through my Jetpack Compose videos, maybe head over to codingwithmitch.com, register, and watch one of my other courses. I got all kinds of high quality courses. If you scroll on down on the homepage, there's the Jetpack Compose one that you're watching right now. There's that course. We have MVI architecture, if you've ever been curious about that. We have my classic powerful Android apps with Jetpack architecture. This shows you everything from, the focus on this one is pretty much database caching. We get data from a real API, we cache it, we basically design an app to work when there's no network connection. That is what this project is all about. We have some UI testing, another UI testing, HILT, which we actually went over in this course. We got clean architecture. This one's probably the best. This is definitely the best course on my website. If you are a professional or you are looking to get into the industry, the skills that you learn in this course are absolutely fundamental. This will give you a big edge in any job environment, whether you're applying or you're already at a job and you want to just improve your skills. This is a really, really, really high quality course. It's hard. Your brain might explode while watching it, but you will learn a lot. You'll learn a lot of really, really fundamental skills. Anything from getting data from the network, caching data, designing different layers, abstracting out the different layers so that you can write unit tests, espresso tests, so UI tests, Dagger, navigation components, everything. It's beautiful. Definitely, this is the best course on the website.